Okay, let us go to pronomial. Pronomials in a set of complex numbers. Up any pronomial, it is in this form of a power n, an, z power n, an minus 1, z power n minus 1, up to a constant number equal to 0. So we're going to see how we can factorize that pronomial, how we can solve a pronomial. That's what we're going to see. For example, examples number one is saying that factorize the pronomial. That pronomial is P of Z. And that P of Z is 3z power 4 minus 5z power 3 plus 5z squared minus 5z plus 2. So we're going to factorize that pronomial. This is a polynomial of degree 4. So we're going to solve that polynomial. So how do we factorize that polynomial? Remember, in a set of real number, we also did polynomial. How we can factorize a polynomial? Remember that what we do, we find what? We start by finding a factor or a root. So here, it is the same. We have to start by finding what? Roots that can satisfy this equation. So our Pz is 3z power 4 minus 5z power 3 plus 5z squared minus 5z plus 2. Then, what we're going to do here, we're going to let like z equal to 1. So if z is 1, we see if it can satisfy what? It can satisfy that equation. So is Pz will be equal to 0? P of 1 will be equal to 0. That is our question. If P of 1 is 0, it means that this z will be what? A root. So P of 1, the answer will be 3, 1 power 4, minus 5, 1 power 3, plus 5, 1 squared, minus 5, 1 plus 2. So then P of 1, the answer is 1 power 4, that is 1, that's 3, because 3 times 1 is 3. 1 power 3 is 1, that is minus 5. 1 power 2, that is 1, then that's 5, minus 5 plus 2. So the answer here is this 5 goes with that 5. 3 plus 2, that is 5. 5 minus 5, the answer is 0. Since P of 1 is 0, so it means that 1 is a root of P of Z. So our 1 is root of P of Z. So we can use like synthetic division to find other roots. So now there we have Z, and our root is 1. We have coefficient of Z power 4, it is 3. Coefficient of Z power 3, it is negative 5. Coefficient of Z squared is 5. Coefficient of Z is negative 5. With a constant is 2. So bring this 3 here. 3 times 1, that is 3. This is negative 5 plus 3, that is negative 2. Negative 2 times 1, that is negative 2. This is 3. 3 times 1, that is 3. That's negative 2. Negative 2 times 1, that is negative 2. Here we get what? 0. So meaning that our pz becomes, if 1 is a root, it means that z equal to 1. That's the root. Our factor is z minus 1, which is 0. So our factor is z minus 1. So here it will be z minus 1 into bracket. So we started with z power 4. So meaning here it will be z power 3. So which is 3z power 3 minus 2z squared plus 3z minus 2. So now, this is power 3. We're going to factorize this polynomial. So let us factorize this, which is 3z power 3 minus 2z squared plus 3z minus 2. We let this one to be 0 in order to find a factor or a root. Let us be equal to 0. So let us also find, we let z to be equal to what? To 1. We see if it can satisfy what? This equation. If we find that z equal to 1 cannot, we will take another root. So that's 3 into 1 power 3 minus 2 into 1 squared plus 3 into 1 minus 2. Is this one equal to 0? So this is 3, because one binary number is 1, minus 2 plus 3 minus 2. So this is 6 minus 4. 6 minus 4, it is 2, and 2 is different from 0. So meaning that z equal to 1 is not what? A root. So let us try to find another root. So since now 1 cannot satisfy this equation, and even if you can see negative 1 also cannot satisfy this equation, because if you use negative 1, it will be negative 3 minus 2, that's negative 5, minus 3, that is negative 8, minus 2, which is negative 10. So negative 10 will be not equal to 0. So what you do to get another root, you let z to be bi. So you use z to be what? Bi. So where there is z, you use bi. So it will be 3 into bracket bi power 3 minus 2 into bracket bi squared plus 3 into bracket bi minus 2 equal to 0. This is like 0 plus 0i. So I power 3, it is negative I. So it will be 3b power 3, negative I, that's negative 3, 3b power 3i. I squared, negative 1. Negative 1 with this negative becomes negative, positive 2, b squared. Then plus 3b I minus 2 equal to 0 plus 0i. So imagine a part together and the other part together. So that is 2b squared minus 2 plus negative 3b power 3 plus 3b I equal to 0 plus 0i. So we have two parts, real part and imaginary part. For the real parts, 2b squared minus 2 will be equal to 0 because it is the real part. For imaginary part, negative 3b power 3 plus 3b equal to what? To 0. So we have two equations. Among of those two equations, you choose one which is very easy to solve. You can see when you compare equation 1 and equation 2, equation 1 is very easy to solve. So let's choose equation 1. So 2b squared minus 2 equal to 0. This implies that 2b squared equal to 2. This implies that b squared equal to 1. B squared equal to 1. So which means that b is plus or minus 1 because b squared equal to 1, we find square root both sides. Square root of 1 is plus or minus 1. So our b is plus or minus 1. And remember our z, we said that z is bi. So which means that our z is plus or minus I. To confirm that this is our true roots or it is the right one, you take this value, you bring it here. If this value satisfies this equation 2 that you have not used, it means that your root is true. For example, if I take 1, it will be negative 3 plus 3, which is 0. If I will take negative 1 power 3, that's negative 1. Negative 1 times negative 3, that's positive 3. Plus negative 3. Positive 3 plus negative 3, that is 0. So meaning that this is a root, a second root. So if for z equal to I, we use it to get what? We use it to solve that third degree polynomial. So which is, we have z, and our root here is I, and that third degree polynomial, it is 3. The coefficient of z power 3, it is 3. The coefficient of z squared is negative 2. The coefficient of z is 3, and a constant which is negative 2. So now, this will be, I put this one 3 down here. 3 times I, that's 3I. So I add, that's negative 2 plus 3I. So I just take this one times this one. It becomes negative 2I. I times 3I, that's 3I squared, which is negative 3. I add, I get negative 2I. Negative 2I times I get 2. So this is 0. So now P of z, it is going to become, remember it was z minus 1. If you remember, into bracket, it is here. Z minus 1 times this one. So now this polynomial, I'm factorizing this one. So I got z equal to plus or minus I. So I've started with z equal to I. If z equal to I, this is a root. The factor is z minus I. This is a factor, z minus I. So it will be z minus I into bracket. Remember, it was power 3. This one is going to become power 2, which is 3 z squared plus negative 2 plus 3I z, then minus 2I. So I'm going to factorize this one, that quadratic equation. So I also have z equal to negative I. I say for z equal to negative I use also synthetic division. I have negative I, z. We have a coefficient of z squared is 3. Coefficient of z is negative 2 plus 3I. And a constant, negative 2I. I put this one down. 3 times negative I, that's negative 3I. I add, I get negative 2. Negative 2 times negative I, that's positive 2I. I get what? 0. So now here, another factor is 3z minus 2 equal to 0. So finally, P of z is 3 is z minus 1, z minus I. Then here for z equal to negative I, the factor is z plus I. That's the factor because you bring it here. So it will be z plus I. Then the last factor is 3z minus 2. So this is how to factorize what? A polynomial. Do you have any question here? I think there is no question. Let us try to do another example. Thank you for this one.